Welcome back to the CS160 programming tutorial. This is the second of our videos, and in this video we are going to review the programming process found in Chapter 1 of the Gaddis textbook. That programming process consists of 9 steps, and we're simply going to go through those 9 steps in order and discuss the purpose of each step. Well, step number 1 is to clearly define what the program is to do. We have to define its behavior, the expectations of the client or the user. This is commonly denoted as defining or specifying the functional requirements. And the functional requirements can generally be divided into 3 categories: the program inputs, or the data it's going to operate on, the computations, and the outputs. And typically the order of the programming statements follows that. We have a subset of statements that get the required input, and then we have a series of operations on those inputs, typically done in the context of assignment statements, and those produce values that we're going to display, and those are the outputs. The second step is to visualize the program running on the computer. This is very much related to step number 1. This pays particular attention to the way in which the user interacts with the program. And you'll probably be introduced into 2 ways the user interacts with the program. One, through basically keyboard input and console output, and the secondly through some kind of simple visual interface that involve dialog boxes. The third step is the use of design tools to create a model of the program. We typically don't go directly from a description of what the program is to do, which is often specified in English narrative, into code. They're typically 1 or more intermediate steps where we create these various models of the program. At the highest level, we might create diagrams using the unified modeling language that describe the architecture of the program. And for a Java program, this would be, what are the classes we're going to use, and how do those classes interact with respect to method calls? We also might use at a lower level a pseudocode, and pseudocode would define the algorithms that implement or describe the behavior of the methods of our classes. The fourth step is to check the model for logical errors. And here's where we want to make sure that the architecture and the pseudocode algorithms we define consistently, completely, and correctly capture the functional requirements. The fifth step, and now we're getting into the implementation part of the programming process, is to enter some code and compile it. And we know that we're going to be using Eclipse, and Eclipse is a very sophisticated program development environment. So it contains within it a text editor for us to enter the code, and it also has a built-in compiler, and it actually compiles our code as we're typing it. Of course, that compiler will detect syntax errors. And it's very nice the way Eclipse does it. It's basically looking over our shoulder, so we can correct the errors on the spot. So typically when we get to the end of a statement, we'll know whether or not there's an error in it, and in Eclipse those are marked by those red squiggly lines. It's very easy to take care of it in that way. And so, as I said, we're going to have several iterations, and each iteration is going to require us to create 1 or more Java statements. And so we might have to repeat steps 5 and 6 several times. That is, enter some lines of code. We may discover syntax errors, so we're going to have to edit them. Our first edit may not be correct. We might have to edit it again. So at the end of this small little iteration, we will have a segment of code that is free from compilation errors and can be executed. We'll then run the program with test data. And we'll correct any runtime errors found while running the program. Well, what are runtime errors? Well, sometimes runtime errors is an error that we make that cause the program to terminate abnormally. Dividing by zero is one of those. And we'll have to correct those. If we find any of those, we're going to have to correct it. And correct it means we're going to have to go back to step 5, enter more code, make sure it's free of syntax errors, and then run it. If it does run to completion, then we'll check to see if the output is correct. So the first thing we want to make sure of is it generates the output we expect. That is all the output there. Do we have all the labels there? Do we have all the headings there? Do we have all the values there? Only after that will we take a closer look at the outputs to see if, as step 9 says, they're valid. And by valid, we mean, does the output that our code generates, does it match the expected output? And where does that expected output come from? Well, it typically comes from the functional requirements. The functional requirements typically have with them, here's some sample inputs and outputs. So we will use the sample inputs and see if our program generates the sample outputs. And we'll repeat those steps as many times as we need to ensure that our program generates the same output as the expected. All right, that's a review of the steps of the programming process. The next thing we'll do is take a look at the structure of a programming assignment and discuss a little bit about the tutorial assignment.